Welcome to the deep dive. We're here to cut through the clutter, giving you the real substance on complex topics, fast.
Yep, helping you get informed without drowning in details.
And today, we're tackling AI agents. These systems that seem to think and act autonomously.
Exactly. They go way beyond basic automation, handling some really sophisticated tasks.
Consider this your shortcut to understanding how these things are actually built, and maybe more importantly, why you should care.
It's definitely timely. The progress in large language models, LLMs, has been incredible.
Right. Their ability to reason, handle different data types, use tools. It's really paved the way for agents.
It really has. Suddenly, autonomous agents feel very real.
So our mission for this deep dive is pretty straightforward. We want to unpack the absolute core building blocks you need for any AI agent.
And figure out when using an agent actually makes sense, compared to older automation methods.
Crucially, yes. And also, how do we make sure they run safely and do what we expect them to do? That seems vital.
Absolutely essential.
Okay, let's jump in. What are those foundational pieces? If you're building an agent, where do you even start?
Well, fundamentally, you're looking at three core components. There's the model, the tools, and the instructions.
Okay. Model, tools, instructions.
Think of it like this. The model is the agent's brain. It does the reasoning.
And LLM itself, yeah.
Exactly. The tools are like its hands and eyes.
Yeah.
They let it interact with the outside world, gather info, take action.
Makes sense. And instructions.
That's the rule book.
Uh,
The guidelines telling the agent how to think and act.
got it. So let's break down the model first. The brain.
Right. The LLM.
Yeah.
It's the engine driving the reasoning, the decision-making, the whole workflow, really.
But not all LLMs are the same, I guess.
Definitely not. They vary quite a bit. Some are much better at handling complex tasks. You can think of it like processing power.
More complexity needs a more powerful model.
Precisely.
Yeah.
They also differ in speed, what we call latency, and of course cost. Some models are much cheaper to run than others.
So you wouldn't just throw the biggest, most expensive model at every single problem.
Generally, no. That wouldn't be very efficient. A good strategy is often to start prototyping with a really capable model, maybe the best one available,
Why start there?
because it helps you establish a performance baseline. You see what's possible, what the agent could achieve under ideal conditions.
Okay. Set the high bar first.
Exactly. Then, once you know what good looks like, you can start experimenting with smaller, faster, maybe cheaper models.
To see if they can still do the job well enough.
Right. Can they meet your accuracy targets? The main goal is hitting those performance requirements first.
And then you optimize for cost and speed.
Precisely. Get the accuracy right, then tweak for efficiency if you can, maybe by swapping in a less demanding model if it still performs.
Okay, model covered. Now, tools. That sounds like how the agent actually interacts with things.
That's a great way to put it. Tools are basically external functions, or APIs. They let the agent connect to other systems.
So it can pull data or make changes.
Exactly. It uses tools to gather context information it needs, and then to actually take actions in the real world or, in other digital systems.
And you mentioned something interesting. It can even work with older systems.
Yeah, that's pretty neat. Even if a system doesn't have a modern API, agents can sometimes use what are called computer use models.
What do those do?
They basically mimic how a human uses a graphical interface, clicking buttons, typing in fields.
Wow, so it can operate legacy software almost like a person would?
In essence, yes.
Wow.
Which is why having standardized definitions for these tools is so important.
Why standardize?
It makes them reusable. You can use the same tool across different agents. It also makes managing everything much simpler, avoids recreating the wheel. Think of a well-organized toolbox.
Okay, so what kinds of tools are we talking about? Are there different categories?
Yeah, we can group them into roughly three types. First, you've got data tools.
For fetching information.
Exactly. Querying databases, reading files, searching the web, the agent's eyes and ears, basically.
Got it. Second type.
Action tools. These let the agent do things. Send an email, update a customer record, maybe hand off a support ticket. These are its hands and feet.
Okay. Data and action. What's the third?
Orchestration. This is where it gets a bit meta. Agents can actually act as tools for other agents.
Agents calling other agents.
Yep. We'll talk about something called the manager pattern later,
Yeah.
which uses this idea, like a supervisor delegating tasks.
Interesting. So collaboration between agents, you mentioned a specific example using Python.
Yeah, the source material shows how you might use something like an agent's SDK. You could give an agent a standard web search tool.
For looking things up online.
Right. And you could also create a custom tool, maybe a simple Python function called save results that writes the search output somewhere like a database.
So you can mix and match pre-built and custom tools.
Exactly. And the key takeaway here is, as you start adding more and more tools to a single agent, things can get complicated.
Too many tools for one agent to handle.
It might become confusing for the agent or just hard to manage. So that's often a trigger to think about splitting the task across multiple, more specialized agents.
Right, keep things focused. Okay, so model is the brain, tools are the interaction layer. What about instructions? Sounds critical.
Absolutely critical. Instructions are the explicit guidelines, the guardrails, defining how the agent should behave.
The standard operating procedures, basically.
That's a perfect analogy. High-quality instructions are crucial for clear decision-making and reducing errors. You need to be unambiguous.
Garbage in, garbage out applies here too, I guess. Clear instructions lead to better results.
Definitely. And the source gives some good tips for writing them. One big one is, don't start from scratch if you don't have to.
What do you mean?
Leverage existing documents. Your company probably already has operating procedures, support scripts, policy docs.
Ah, so codify the existing knowledge for the LLM.
Precisely. You're teaching the agent based on what your organization already knows and does.
Makes sense. What else makes for good instructions?
Breaking down complexity. Prompt the agent to think in smaller, clearer steps. Don't give it one huge, vague goal.
Decompose the problem.
Exactly. And for each step, define very clear actions or outputs. Be specific. Instead of just get customer info, say, ask the user for their order number, or call the get customer details API.
Specificity reduces ambiguity, even down to the exact wording it should use with a user.
Yes, that can be important too, for consistency and clarity.
What about unexpected situations? Edge cases.
Good instructions plan for those.
Yeah.
You need to capture potential edge cases and tell the agent how to handle them. Maybe use conditional steps.
Like if this happens, then do that instead.
Right. If the user doesn't give an order number, ask for their email. Provide alternative paths.
And apparently you can even use AI to help write these instructions.
Yeah, that's a fascinating development. You can potentially use advanced LLMs to analyze your existing documents and generate draft instructions automatically.
Using AI to bootstrap its own instruction manual. Very meta.
It is. It shows how these tools can compound.
Okay, so we have the model, tools, and instructions, the core build. Now the big question. When does it actually make sense to build an agent versus using, more traditional automation?
That's fundamental. Agents really shine where traditional rule-based systems struggle.
Like where things aren't just simple yes-no decisions.
Exactly. Think about that payment fraud example. A traditional system is like a checklist. Does it tick these boxes? Yes, no.
Very rigid.
Very rigid. An LLM agent, though, can act more like a seasoned investigator. It can look at the whole picture, understand context, spot subtle anomalies.
Even if it doesn't perfectly match a predefined rule.
Right. That ability for nuanced reasoning in ambiguous situations is key. Traditional automation follows the exact same steps every single time. Agents can adapt.
So they go beyond that basic if-then logic. What are the specific signs that say maybe an agent is right here?
The source points to three main criteria. First, complex decision-making. Workflows needing nuanced judgment, handling lots of exceptions, or decisions that really depend on the specific context. Like approving a tricky customer refund that isn't straightforward policy.
Right, where a human would need to weigh different factors.
Exactly. Compare that to a system just blindly applying a rule.
Okay, complex decisions. What's number two?
Difficult to maintain rules. If you've got a system with a massive, tangled web of rules.
Like legacy systems sometimes have.
Yeah, or complex compliance areas like, say, vendor security reviews, where regulations change constantly. If updating those rules is expensive and error-prone, an agent might be better.
Because the agent can learn and adapt instead of needing constant manual rule rewrites?
Precisely. It's potentially more flexible and maintainable long-term.
Makes sense. And the third criterion?
A heavy reliance on unstructured data.
So dealing with things that aren't neatly organized in databases.
Exactly. Interpreting natural language in emails or support tickets, extracting meaning from documents like insurance claims, having conversations.
Themes that involve human language.
Right. LLMs are naturally good at that.
Right.
Whereas traditional automation really struggles with the messiness and variability of free-form text and conversation.
So lots of text, emails, chat logs, good signs for an agent.
Definitely strong indicators. But there's a caution here.
Oh.
Before you dive into building an agent, Really validate that your use case hits at least one of these criteria strongly.
Why?
Because if it doesn't, a simpler deterministic automation, just a fixed set of steps, might be perfectly adequate and probably less complex to build and manage.
Don't use a sledgehammer to crack a nut, basically.
Exactly. Don't over-engineer it if you don't need to.
Good practical advice. Okay, so assuming an agent is the right choice, how do we make sure it runs effectively and safely? The outline mentioned orchestration and guardrails.
Right. Once you've got the model, tools, and instructions, orchestration is about how the agent actually executes the workflow. How does it put those pieces together?
How it runs the process.
Yeah. And the suggestion is usually to start simple and add complexity gradually. Don't try to build the most complex system imaginable right out of the gate.
Makes sense. What are the main approaches?
Broadly, you've got single-agent systems and multi-agent systems.
Okay, single agent first. Sounds like one LLM doing everything.
Pretty much. It's one model with its tools and instructions running the whole workflow, usually in some kind of loop.
A loop.
Yeah, the source calls it a run. The agent keeps processing, maybe interacting, calling tools, until it hits an exit condition.
Like what?
Could be successfully calling a final answer tool,
Hmm.
producing a specific structured output, hitting an error it can't resolve, or maybe just reaching a preset limit on how many steps it can take.
So it keeps going until it's done or gets stuck or time's out.
Basically, yes. Now, managing complexity in just one agent can get tricky if the task is involved.
How do you handle that without immediately jumping to multiple agents?
One key technique is using prompt templates with policy variables.
Okay, what does that mean?
Instead of writing dozens of slightly different prompts for every situation, you create a flexible base prompt. Then you insert variables like customer name, issue type, account status as needed.
Ah, like a mail merge, but for the agent's instructions.
Kind of, yeah. The source gives an example for a call center agent prompt. It makes the whole system much easier to manage and adapt. One template, many scenarios.
Clever. So when do you bite the bullet and move to multiple agents?
The advice is generally, push the single agent as far as you reasonably can first. Multiple agents add overhead, communication complexity.
It's not automatically better.
Right. But you might consider splitting if your instructions get really convoluted. Tons of if-then-else logic making the prompt template a nightmare.
Okay. Unmanageable logic. Anything else?
The other trigger is tool overload.
Mm-hmm.
And it's not just the number of tools, but if they're too similar or overlap a lot.
So the agent gets confused about which one to use.
Exactly. If you can't fix that by just defining the tools more clearly, then having specialized agents, each with a smaller, more distinct set of tools, might work better. Prevents the jack-of-all-trades problem.
Got it. So complexity or tool confusion pushes you towards multi-agent. What do those look like?
The source highlights two main patterns that cover a lot of ground. First is the manager pattern.
That's hierarchical.
It is. You have a central manager agent. Its job is to coordinate other specialized agents. And it does this by calling those specialists as tools.
Ah, back to agents as tools.
Exactly. This pattern is great when you want one clear point of control for the whole workflow and maybe for handling all the user interaction, like a project manager.
Can you give an example?
Here, the source mentions a translation manager. A user asks for a translation. The manager agent figures out the languages involved and then calls, say, a Spanish translation agent tool, or a French one or an Italian one, gets the results back, and presents them.
So the manager delegates the specific translation tasks.
Precisely. The second main pattern is decentralized.
Less hierarchy.
Yeah, think of it more like peers. Agents hand off tasks directly to each other based on who's best suited for the next step.
How does a handoff work?
In the agent's SDK context, a handoff is actually treated like a special kind of tool or function call. When Agent A calls the handoff to Agent B function, execution just transfers straight to Agent B, usually along with the current conversation history.
Like passing the baton in a relay race.
Good analogy. This works well when you don't need that single central controller. And it's okay for specialized agents to take over and maybe interact directly with the user for their part of the task.
Like in customer service, triage passes to tech support, who passes to billing.
Exactly like that. A triage agent assesses the issue, hands off to tech support if it's technical. Tech support solves it, or maybe hands off to a sales agent if the user wants to upgrade.
Okay, manager versus decentralized handoffs. Seems flexible.
It is, and it's worth noting this SDK approach is often described as more code-first and flexible compared to some frameworks where you have to define the entire workflow graph declaratively up front.
Right, more dynamic. Okay, structure covered. Now, the really crucial part, guardrails. How do we keep these things safe and on track?
Guardrails are non-negotiable, really. Think of them as layers of defense. One single guardrail probably isn't enough.
Multiple layers for resilience.
Exactly. You combine several specialized guardrails. And, super important, these are in addition to standard security practices like authentication, access control, etc. They don't replace basic security.
Right. So what kinds of guardrails are we talking about?
Several types. You might have a relevance classifier.
To keep it on topic.
Yep. Flags if the user tries to take the conversation way off track. And there's a safety classifier.
For dangerous stuff.
Right. Detecting harmful inputs like attempts at prompt injection or asking the agent to do something malicious. Then things like PII filters.
Protecting personal info.
Crucial. Preventing the agent from accidentally leaking names, addresses, credit card numbers. Moderation tools can also be used to flag harmful content, like hate speech or harassment.
Okay, filtering bad inputs and outputs. What else?
Tool safeguards. This is interesting. You can assign risk levels to your tools.
Like sending an email is low risk, but deleting a database record is high risk.
Exactly. And based on that risk rating, you can trigger extra checks, maybe even require human review before a high-risk action is executed.
Adds a layer of oversight for critical actions.
For sure. You also have basic rules-based protections, block lists for certain words, limits on input length, maybe using regular expressions to validate formats.
Simpler checks.
Simpler but still useful. And finally, output validation, making sure the agent's responses sound right, they fit your brand voice, they aren't weird or off-putting.
A whole suite of checks and balances. How do you decide which ones to build first?
The source suggests a practical heuristic. Start with privacy and safety PII filtering, safety classifiers. Those are usually table stakes.
Focus on the biggest risks first.
Right. Then add more guardrails based on actual failures or issues you see when testing or in early deployment. Learn from mistakes.
Reactive improvement.
And continuously refine them. Optimize for both security and a good user experience. Overly aggressive guardrails can be annoying.
Finding the right balance. There was an SDK example for guardrails too.
Yes. It showed setting up an input guardrail. Imagine a function, maybe called churn detection tripwire. You register that as a guardrail.
What does it do?
It runs alongside the main agent processing. If the user's message sounds like they might be about to cancel their service, high churn risk, the tripwire function could trigger an exception.
And stop the agent from maybe saying the wrong thing.
Exactly. It prevents the agent from proceeding down a path that might make the churn situation worse, perhaps by automatically routing to a specialized retention agent or a human. It's optimistic execution with a safety net.
Clever. Catches problems concurrently.
It is, and this ties into the last crucial safeguard, planning for human intervention.
Having a human in the loop.
Absolutely.
Okay.
It's not about admitting failure. It's a critical part of making the system robust, especially early on. It helps you find problems, improve performance, and just build confidence.
So the agent doesn't have to handle 100% of cases perfectly right away.
Not necessarily. You need a way for the agent to gracefully say, I need help, and hand off to a person.
When would that happen?
Two main triggers. One is hitting failure thresholds. Maybe the agent tried 3 times to understand the user and failed. Time for a human.
Repeated failure.
The other is encountering those high-risk actions we talked about. Maybe for really significant things like large financial approvals, you always require human sign-off, at least initially.
Until you really trust the agent's judgment in those scenarios.
Exactly. It's all about building trust incrementally and ensuring responsible operation.
That makes complete sense. Build in safety valves.
You have to.
Okay, this has been incredibly enlightening. If we were to boil it down, what are the absolute key takeaways for someone thinking about building AI agents?
I'd say the main thing is, agents are a genuine leap forward for automating workflows. They can reason, use tools, handle complex steps in ways rule-based systems just can't.
Going beyond simple automation.
Definitely. But to build them reliably, you need that solid foundation. A capable model, well-defined tools, and really clear instructions. That's your bedrock.
Model, tools, instructions. Got it.
Then think carefully about orchestration. Start simple, maybe single agent, use prompt templates well, and only move to multi-agent setups when the complexity really justifies it.
Choose the right pattern for the job.
And layer in those guardrails from the start. Privacy, safety, relevance, tool safeguards, human intervention points. They aren't optional. They're fundamental for safe, predictable operation.
Safety isn't an afterthought.
It absolutely cannot be.
So the overall advice seems to be, understand the basics, Know when agents are truly the best fit, start smart, build incrementally, and prioritize safety at every step.
That sums it up perfectly. Do that, and you can start tapping into the real power of agents automating not just simple tasks, but entire, intelligent, adaptable workflows. It's a really exciting space.
It really is some fantastic points to think about there. Thanks so much for walking us through all that.
My pleasure.
And thank you for listening to the deep dive. Hopefully, that gives you a much clearer picture of what goes into building effective AI agents. Now, maybe take a moment and think about the workflows you deal with. Where could this kind of intelligent automation make a real difference? Something to ponder. Join us next time for another deep dive.